So in the last class we were talking about some technical words. We have discussed about active passive, we have discussed about linear non-linear, we have discussed about time invariant and time variant. Today we will take some more term, okay, and that word term is the analog and digital. Okay, when I say analog system or analog signal, in fact there is a one subject called signal and system that is being studied in your electronics. People have their own subject, but it is there common to electrical also. It is similar to the circuit theory only, but where there they not only they put in the form of signal, but here we have used the word analog. Now when I say analog, it means the signal is continuous. The signal is continuous, whether voltage or current or power or energy, whatever may be the situation, is in continuous form. And if discontinuity is there, that is periodic. If discontinuity is there, that is called, that is periodic, that it repeats itself after a particular period of time. So graphically, if I have to represent with the time any electrical quantity, say voltage or current or power, then you will find, are you seeing any, it is suppose starting from here, from time t is equal to 0. So what you find for all t values, t 0 पे कुछ वैल्यू है, मान लो ये 1 सेकेंड है, suppose this is 1, this is a 2, this is a 3, this is a 4, this is for 5, and in between 1 and 2 also, between 0 and 1 also, you have a particular value of voltage, current or power, is it not? So signal is continuous. So this type of signals come under the category of analog signal. Is it clear? So you have seen your voltmeter, that box type voltmeter, okay, the needle was there, okay, so that instrument is called analog instrument. That instrument is called analog instrument because signal goes continuously, it deflects the needle, and thus the needle says it is 1 ampere or 1 volt or whatever may be the situation. Is it clear or not? So that signal are called analog signal, and that devices are called analog devices. Analog voltmeter, analog ammeter, analog power meter, watt meter, whatever may be. Is it clear? Then there is come another word called digital. Now when I say digital, what comes in your mind? When I say word digital, what comes in your mind? You have a digital electronics in your next semester. Okay, digital simply means you might have learned something in your first year syllabus also in your electronics. Is it clear? That is converting any signal into 0 or 1. Expressing any signal in 0 or 1s. There are only two digits are there, 0 and 1. Okay, so we are expressing any digit, 5. Now 5 will not be written as 5, but it will be expressed in the form of 0 and 1. Similarly 10, 20, 30. In fact, you know, you have a computer have one or more than one parts. One is your processor, which is called CPU, central processing unit. What actually happening in the central processing unit? In the central processing unit, whatever you type in the form of input, okay, that is converted into binary numbers. These two numbers are called binary numbers. Binary means two digit only, 0 and 1. So in the computer, when what is happening in the processor, every input data, whether alphabet or whether your numerical value, is being converted into 0 and 1, and therefore that signal is called digital signal. Is it clear? So computer understand only two digits, 0 and 1, and therefore there is another conversion is there which convert the analog signal into digital signal. There is a converter is there. You will learn in the instrumentation that A to D converter is there, analog to digital, where any analog signal is converted into digital signal, and then it is being passed to the processor for processing the system. When you type 5 plus 2, You know answer is 7. How computer knows? Computer does not know 5, computer does not know 2, but analog to digital converter will convert 5 into a digital number, 2 into digital number, plus signing on to a digital number, and then it will do the processing of the digital numbers, and therefore they will give the result 7. But this process is going on so fast in nanosecond that immediately you type it, you get the answer. Is it clear? The processing speed is so fast, it takes nanosecond only. You may take millisecond or you may take seconds, but the computer process is taking how much? Nanosecond. And you know the speed, the frequency of the today's processor is in gigahertz. 2.4 gigahertz and 2.3 gigahertz, like this. Whenever you go to purchase a computer, you just mention this type of, that I want a processor of this much gigahertz. So gigahertz is indicating what? That the processing time is of nanosecond. You got my point or not? So in our electrical technology, you will come across the analog signal also, analog devices also, and also digital signal and digital devices also. So whatever you are seeing, we have some multimeter. The multimeter you have seen in your laboratory, okay? That display is in the form of digital. Is it clear? So we are procuring some digital AC and DC voltmeter, DC and AC digital emitter also. Very soon you will be exposed to them. Is it clear? This is clear the word? Okay. Next come another. Now types of sources. Types of sources. Before type of sources, let us take another word, unilateral and bilateral. Unilateral and versus what is a unilateral device and what is a bilateral device? This you have to understand it. If the terminal property, please listen what I am saying. If the terminal property, suppose you have a device like this. Now this device has two terminals. One this one and another this one. If the terminal properties of any component or element or device remain unchanged by reversing the voltage or current, that device is called bilateral element. Listen what I am saying. The terminal property of any element or device remain unchanged by reversing the polarity, okay, that device is called, or that component is called bilateral. And if the terminal property changed by changing the polarity, okay, then device is called unilateral. Now let us take example. I take example of resistor. So what is terminal property? Terminal property remain unchanged in what? Bilateral elements. Is it clear? By changing the polarity. By changing the polarity. Is it clear? And if it is changed, okay, that is called unilateral. Is it clear or not? Okay, now let us take an example. I have taken a resistor, okay, of say, you know the value, you know it is of value 5 ohm. Okay. Now there are two terminals, one is 1 and another is 1 dash. Clear? Now I am applying an voltage across it. $10 volt. with plus sign on one side and minus sign on one dash. This is clear? Now you know you can find out the current. You can find out the current. How much will be the current? I will be equal to 10 divided by 5. It comes out to be 2 ampere and it will flow in this direction. Clear? So current magnitude comes out to be how much? A terminal property current comes out to be how much? 2 ampere. Do you agree or not? Okay. Now I do another experiment on the same resistor. Okay. What I will do? What I do? I have again applied a voltage source of 10 volt to the same element resistor which is of value 5 ohm, but only a simple, a very small change I have made. What? I have reversed the polarity. That is, one terminal is connected to negative terminal of the battery and one dash is connected to positive, just opposite of the very first one. यहाँ पे वन किससे कनेक्टेड था? पॉजिटिव से. और नेगेटिव किससे कनेक्ट था? वन डैश से. यहां पर नेगेटिव किससे कनेक्ट है? वन से. और पॉजिटिव किससे कनेक्टेड है? क्लियर? दिस इज क्लियर और नॉट? नाउ फाइंड आउट व्हाट इज द वैल्यू ऑफ द करंट. 10 divided by 5. How much? Are these two quantities are same? Yes, means the terminal property has remained unchanged by reversing the polarity sign. Is it clear? Hence resistor is a bilateral element. Resistor is a bilateral element. Is it clear? Similarly, your other two devices, what are the other two devices? So your resistor, then your, what is the next element? Inductor. And what is your capacitor? In some books you will also find this symbol. Is it clear? These two lines should be of equal size, equal length. Okay, if they are of unequal length, then it will be a sign of battery. Mind it. Okay, if these are of equal length, then it is of capacitor. Is it clear? So these all three elements, they are which category? Bilateral element. This is clear or not? This is clear? They come under the category of bilateral element. Okay. So now next, what is unilateral? What is a unilateral? Whose terminal properties change by changing the polarity. How? Let us take example of unilateral. So unilateral example is your diode. Unilateral example is your diode. How? Diode have two junction, P and, do you agree? Okay. Now I make a circuit like this. I apply a battery of any volt, suppose V volt, this is plus sign, this is minus sign. Now this condition, in this condition, which type of biasing is this called? This is termed as an forward biasing, where the P is being connected to the positive terminal and the N is connected to the negative terminal. So this is called forward biasing. Okay. Now clear? So in the forward biasing, what is the characteristics of the VI characteristics of the diode? This type of there? This type of there or not? Okay, there is a cut-in voltage is also there, and like then it is a linear type. Is it clear? VI character. Do you agree or not? Now I again do the same thing. What is? Reverse the terminal. Reverse the. Should I reverse it? Okay. Then how my circuit will look like? So this will be termed as an which biasing? P is being connected to negative and N is connected to positive. So this will be called as an reverse biasing. So in reverse biasing, is the VI characteristics remain same? VI characteristics remain same? No. It is a very small amount of ampere current flows during the reverse biasing, and at a particular voltage there is a breakdown is there. Okay. So the terminal property is changed. Do you agree or not? Okay. In some books it is being drawn like this. It is being, sorry, it is not like this. Like this. Okay. So this is not in similar with the forward biasing characteristics. Hence diode is which type of element? Diode is which type of element? Diode is a unilateral element. This is clear or not? So we have gone through many words: unilateral, bilateral, linear, non-linear, time variant, time invariant, continuous, digital, analog and digital. Okay, like this. Now another point is type of sources. What is that? Type of sources. So what is the type of sources? That is very important. Now broadly, sources has been, now you know, you are using source means which provide power supply to the different elements of the circuit. Is it clear? Resistor, capacitor are there, they are all passive element. In order that they should work, we have to provide an external power supply. Okay, so how many type of power supply or how many type of sources there are in our circuit theory? Broadly we are classifying into two forms: independent sources, and another is dependent sources. Clear? What is independent sources? What is dependent sources? Okay, that we will discuss it. Okay, another classification of sources: DC sources and DC means AC means alternating. This is the abbreviated form, you have just expanded it. But what is the meaning of DC? What is the meaning of DC? Which supply you consider as a DC? The supply which is unidirectional in nature. Mind it, generally the misnomer concept is there, one which is constant. हम DC का डेफिनेशन कैसे देते हैं? जो कांस्टेंट है, मगर हकीकत में DC का मतलब क्या हुआ? Which is unidirectional in nature. In this unidirectional, it may be constant or it may be fluctuating or pulsating. Is it clear? So DC means one which is unidirectional, एक ही दिशा में. Unidirectional का क्या मतलब हुआ? एक ही दिशा में जो बह रही है वो सप्लाई क्या कहलाएगी? DC. अब वो उसमें कांस्टेंट भी हो सकती है या फिर पल्सेटिंग भी हो सकती है. पल्सेटिंग डजंट मीन्स दैट इट है पॉजिटिव नेगेटिव. पल्सेटिंग मीन्स अप एंड डाउन, कभी राइज कर रही है, कभी कम हो रही है, कभी 5 वोल्ट, कभी 3 वोल्ट, कभी 2 वोल्ट, कभी 5 वोल्ट, फिर वापस कभी 3 वोल्ट. इज इट क्लियर? सो DC means one which is unidirectional. AC means which is bidirectional, which have positive also and negative also. So I will just citing some example of DC. This is a voltage. So this is DC. Do you agree? Another example I am citing. This is a example 1. Example 2. This is a time T. This is a V. Is this DC? Is this DC? Do you agree? Is it DC? Yes, is it DC? Because it is on the positive side only, and but it is pulsating. Sometimes say this is suppose 5 volt, this is 6 volt, this is again 5 volt, like this. Okay, but magnitude is always positive. It is called pulsating DC, and this type of pulsating DC you obtain in the which device? Rectifier. You obtain in the rectifier. Is it clear? रेक्टिफायर में आपको पल्सेटिंग डीसी मिलती है. फिर आप उसके बाद क्या लगाते हैं? फिल्टर्स. क्या लगाते हैं? फिल्टर्स, ताकि आपको एक कांस्टेंट डीसी मिले. इज इट क्लियर? एसी मींस which have both positive value and negative value, that can flow in both the direction, and the best example is your so called sinusoidal waveform. Okay, this is a very peculiar waveform. In fact, this is the only waveform which we are getting in our household for industrial supply or any. What is the name of this? Sinusoidal waveform. Okay, now I give another example. Is this AC? Is this AC? Yes. Okay, so don't put such type of concept that only sinusoidal is AC. It can be a square waveform, it can be a rectangular waveform, but which have a positive as well as negative. It can be a sawtooth. You know the waveform of sawtooth? Like this. This is what called sawtooth waveform. Why it is called sawtooth waveform? The shape looks like the tooth of the saw. Saw देखिए, आरी. आपने आरी देखी कारपेंटर के हाथ में, लकड़ी जिससे काटता है, उसके ऊपर जो दांते होते हैं, ठीक है, वो इसी शेप के होते कि नहीं होते? That is why it is called sawtooth waveform. You got my point? So you can have the different types of waveforms, AC waveforms, which have a positive as well as negative halves. Is it clear? So this is clear. What is AC? What is DC? Another classification, first classification, dependent and independent. I will tell you later on what is dependent, what is independent. But one more classification, DC and AC. Now in the independent and dependent case, okay, there is another classification. First of all, understand what do you mean by independent. Independent means the source which have their own energy, which are not dependent on other for their energy. Is it clear? एक सोर्स है, ठीक है, एक बैटरी है, तो बैटरी में खुद का अपना चार्ज है और उसी कारण वो आगे सप्लाई वोल्टेज या करंट दे रहा है. Is it clear? Is it clear? That type of sources are called which have their own energy. Sources which have their own energy, which are not dependent on other sources or other elements, they are called independent sources. Is it clear? And what is dependent? So independent which have their own energy. Dependent which depends upon some other sources or element in the circuit. Okay, these dependent sources you will find in electronic circuits, but we will study in our circuit theory also. Okay, so independent is very clear. So example, this is a battery of V volt. This is which it comes under category of, this come under the category of independent source. Clear? Now mind it, one important thing, that whenever you write down a DC sources, always put polarity sign. Keep in mind, whenever you write down DC sources, polarity is must. Okay, no doubt the bigger one is showing positive, but you have to mark in the circuit also that this is positive and this is negative. Is it clear? Okay, so this is very important. As I have already told you, sources can be positive and negative. Sources can be DC and AC. Okay, so this is a DC source. This is I am representing, and the sinusoidal signal is represented. This is an AC source. It is an AC source. In AC, in general, we do not mark any polarity, because one which is positive now, after some time it will become negative, and after some time it will again become positive. So we do not mark any sign, but mind it what I am saying, for our analysis purpose, mathematical analysis purpose, we have to take into consideration, we have to give one sign to any one terminal. In general AC सोर्स में पोलरिटी साइन नहीं लगाते हैं, लेकिन जब हम न्यूमेरिकल करते हैं, when we solve the numericals, then we have to assign one terminal as a phase, therefore automatically other became neutral. Or therefore generally you will find in some foreign author books or some Indian author books also, a plus sign is written. A plus sign is written means that the time you are doing the analysis of that circuit, you will consider this terminal as plus, and thereby other terminal definitely became minus. Is it clear? Though it is inappropriate to say that in AC there is a polarity is there, because polarity keeps on changing. One which is becoming phase, after some time it will become neutral. One which is positive, after some time it will become negative. But for our mathematical purpose, we always assign one terminal as an positive and therefore another became negative. तो केवल एक प्लस साइन लिखते हैं, तो इसका मतलब ये होगा कि ये हमारा फेज है और दूसरा क्या हो गया, न्यूट्रल यानी नेगेटिव. You got my point or not? But in general, the plus minus both sign are not being placed. If it is placed, it is indicating that it is an DC source. You got my point or not? So today I am ending here, okay, with this much of background. What are sources, independent and dependent? Then what are your, what are dependent sources, what are independent sources, what are DC sources, what are AC sources. Tomorrow I will more classify these independent and dependent sources. Is it clear? These four type of sources are very important. Okay, I have highlighted only the example of independent sources. Tomorrow I will give you the example of dependent sources, and in all we will have a four independent sources. Also we will have four type of sources. Is it clear? And independent also we have again two type of sources. Is it clear? So that we will discuss tomorrow. Today I am ending. Any doubt, any question? Okay, so thank you very much.